Welcome back to the channel. This video is on latitude, and in the Earth as a System playlist, we're looking at the definition of latitude and how this applies to our planet in creating symmetrical zones and areas from north to south on our planet, looking at the tropics, mid-latitudes, and the polar regions. This is the Earth Science Classroom. Latitude is a word that means a line on a map which are called parallels, which go north to south across our planet. They are imaginary, and when combined with the lines of longitude called meridians, they form a complete coordinated system able to map the planet and know exactly where you are in terms of your location. This is very beneficial for navigating, for trade, commerce, economy, for anyone on the planet wanting to traverse across the Earth's surface. Historically, latitude has been understood since the days of the Polynesians around 400 BC and the Phoenicians even before that around 1500 BC, where they would use stars to navigate and understand that as you move across the Earth's surface, the position and location of the stars would change. Then in ancient Arabia, the height of the stars was calculated to understand where you were on the Earth's surface, and then Hipparchus in ancient Greece took it further in 120 BC, whereby the establishment of latitude as a means of location and mapping was official. Then Marinus of Tyre in 120 AD started to assign very accurate maps using both latitude and longitude to coordinate locations. By using the equator as our starting point on the Earth for latitude and then drawing the angle at which the certain latitude creates around the planet is called an arc. Now, this arc degree is latitude, and it's created because our planet is an oblate spheroid. It's not a perfect sphere. It's a little bit longer around the circumference as it is from north to south, which is called meridional distance. So the circumference is 24,901 miles, and north to south is 24,860 miles, so a difference of 41 miles. It may seem a small difference, but that creates our shape, which is called an oblate spheroid, not a perfect sphere. So latitude is in relation to the equator, how far north or south you are on the Earth's surface, and that is created by the angle when using the equator as our starting point. And this is reflected in the units of measurement of latitude, which is the arc or the curve line around the planet. The arc degree equals 1 degree of latitude, north or south of the equator, going up to 90 north, which is North Pole, and 90 south, which is South Pole. Now, each 1 degree of latitude, or 1 arc degree, is equivalent to 69 miles along the Earth's surface. So latitude is expressed with certain units of measurement. First, we have the number for degree, then we have a number for minutes, and a number for seconds. So it becomes this subdivided, more accurate and precise location of latitude, which is created between the arc, the angle of the equator, to where you are on the Earth's surface. So let's say 41 degrees, 33 minutes, and 45 seconds. That would give an accurate location of your latitude on the Earth's surface based on the northern or southern hemisphere. So we have degrees first, then that is subdivided into minutes, or an arc minute. There are 60 arc minutes in 1 arc degree, and then we have 60 arc seconds in 1 arc minute. So we get these subdivided numbers allowing for increased accuracy of the latitude location, shown by these coordinates. When discussing the key features of latitude, latitude is in relation to temperature, in relation to seasons, which we'll get onto later, and in relation to the movement and distribution of heat around our planet, so differential heating. Now, we start with the equator, which is 0 degrees latitude. That's our starting point, and from there we divide our planet into 2 halves or two hemispheres, the northern hemisphere and the southern hemisphere. Now, to differentiate between the two hemispheres, we have to add in the letter N for north or the S for south. So looking at the extremes of latitude, we start with the equator and then we end with the poles. 90 degrees north is the North Pole and 90 degrees south is the South Pole, because when you intersect a line from the poles down to the equator, it creates a right angle triangle, so 90 degrees. And the other parallels drawn here are the angle from the equator. So we can draw in the 30-degree north and south parallel, and then in between that we can also draw in the Tropic of Cancer and Tropic of Capricorn, both 23.5 degrees away from the equator. North and south, north being Cancer and south being Capricorn, are named the sun's position during the summer solstice, both in the northern hemisphere for Cancer and the southern hemisphere for Capricorn. The sun is directly overhead at this latitude or along this parallel. Now, in between the two tropics, we have the equatorial region and generally the tropics, which is a concentration of solar radiation, so it becomes warm and hot. Then we move further north and south away from the equator. We draw in the parallel for 60 north and 60 south, and we are forming the mid-latitudes between 30 and 60 degrees either side of the equator. As you can tell, these zones or areas are symmetrical. They're both the same in the northern hemisphere as they are in the southern hemisphere. So the mid-latitudes are between 30 and 60. Then we have the next lines we're going to add in, which is the Arctic Circle and the Antarctic Circle. The Arctic Circle in the northern hemisphere is 66.5 degrees north, and the Antarctic Circle in the southern hemisphere is 66.5 degrees south. Now, these parallels are there to distinguish the solstice, winter or summer solstice in the northern and southern hemispheres, based on the sun not setting or not rising and having that constant darkness or sunlight in the extremes due to the seasonality and the actual tilt of the Earth, creating these polar regions to have extremes of daylight or nighttime, depends on the time of year and the position of the Earth in relation to the sun. And then we have, again, the last point on the Earth's surface, which is 90 north and 90 south, denoting the poles. Now, from this, we can establish why and understand why the polar regions are extremely cold compared to the equator is because of the axial tilt and also the shape of the Earth and the direction and vector of the incoming solar radiation, being that when the radiation hits the Earth's surface at high latitudes in the polar regions, it's going to be spread out and less concentrated, and then even more accentuated when you have the tilt and the actual inclination pointing away from the sun during the winter in both the northern hemisphere and also in the southern hemisphere, accentuating that lack of concentrated heat, and even above the Arctic Antarctic circles, the inability for the sunlight to reach those high latitude areas, causing prolonged darkness and a severe drop in temperature. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.